cutting problem. What is this problem is, see, suppose I'm giving a question. Suppose we have this kind of system. Suppose we have a object is hanging here. Okay, then we have a spring and we have this kind of system. Or we can take suppose one more. Okay, we have this. Okay, so this is suppose MA, MB and MC. So what we are going to, this is not string cutting problem, not a spring. Spring is involved in the system, but we have string cutting problem. S-P-R-I-N-G, not a spring. Spring is not cut, but string is cut, and we have the string involved in the system. Okay, what I'm saying is some string will be cut in this diagram, and we will have the spring involved in the system. So how do we solve? What kind of questions are asked? So we can take a question. We have this kind of system, and the masses are given. Suppose this mass is 2 kg, this mass is 3 kg, and this mass is suppose 4 kg. So these three masses are given, and if we now cut this string, if we cut this string from here, we have to find accelerations of the three objects just after cutting the string. If lower string is cut, find accelerations of three blocks. Accelerations of three blocks just after cutting the string. Okay, so this is the question. So what is the main thing to learn, or what is the main concept to learn here is, the moment you cut a string, the tension in that part becomes 0. Okay, and that part tension is 0. But if you have a spring in the system, the spring tension will not be 0. The force inside the spring will not be 0. The force in string will become 0. This string will have 0 force, but the force in the spring will not be 0. The spring will have the force which is it will take some time to contract or expand. Whatever the position, same configuration will remain immediately after cutting the string, and it will change after some time only. So immediately after, there is no this. Okay, so first we will see what are the, initially the tension here will be, suppose tension here is 2 kg, so 2 kg into G, so MAG. Tension so that is how much? That is 5 into 10 meter per second square. Okay, so it will be 50 Newton. And similarly, in this one, the tension is how much? Here the tension, if you write TC, the tension here will be equal to MA plus MB plus MC equal to into G, whatever we write into G. So it will be how much? It is 3, 1, 2, 3, 4. So total is 9. So 90 Newton. Okay, so 90 Newton is here. After cutting the spring, this one will become 0. Okay, this one becomes 0. So what will be condition after cutting? After cutting, what will be condition for MA? So MA it will be free falling. MA will have free fall. MA is having only one force, that is MAG. So its acceleration will be G. So that is 10 meter per second square. Okay, down. This is for A. Now for B. For B, if we see from upper side, that is 50 Newton. 50 Newton is pulling it in upward direction. But in downward direction, there is no tension. The tension has vanished. Only weight is acting. The weight is how much? MBG. That is how much? 3 kg into 10. So 30 Newton. So what is happening? You can see upward tension is still acting. The T2 is still acting here. But the downward tension which was there from the string has been cut. So downward tension is not acting. Only weight is acting. So net will be what? The 50 Newton upward. 50 minus 30 Newton upward. So the acceleration of B will be 50 Newton upward minus 30 Newton divided by its mass, that is 3 kg. So it will be 20 by 3 meter per second square up. Okay. Now if you see for MC, this is for B, this is for A. Okay. Now for C, if you see, for C, spring is there. So spring will have same tension 50 Newton down, then 90 Newton up, which was there, and then its weight was 4 kg. So 40 Newton or MCG, that is 40 Newton. So you can see the forces are balanced, 19 up, 90 up, 50 and 40 down. So acceleration of C is 0. So acceleration of C will remain 0, B will start moving up, A will start moving down. Okay, with these accelerations.